Dear listeners, welcome to this talk. My name is Brian, and I am accompanied by Tommy. Today, we have the honor of presenting you the manuscript, Deep Quality Estimation,
DQE.
Creating Surrogate Models for Human Quality Ratings.
Side note, on the bottom, you can find the author's contact and a QR code leading you to the paper on archive. Brian, what was the motivation for this research?
2021 marked the 10th anniversary of the BRATS Challenge. The challenge happening here within the scope of MICCAI leads to the emergence of new glioma segmentation algorithms every year. Today, many of these segmentation algorithms are available through BRATS Toolkit, a modular toolkit for glioma segmentation that enables data pre-processing, segmentation, and fusion of segmentation maps.
Feel free to check it out on GitHub.
However, even though they are available, the algorithms usually still do not find their way into clinical practice.
Oh, why is that?
There are many reasons for that. One is that the algorithms do not always produce perfect segmentations. This, in turn, leads to trust issues with clinical practitioners. Quality monitoring represents a valid approach to tackling his problem. The authors previously presented a method for fully automated method for this.
However, this was dependent on ensembling multiple algorithms, right?
Exactly. In this work, the authors eliminate the dependency on ensembles. The goal was to create a surrogate model for a radiologist to judge the quality of segmentation maps.
A surrogate model? Like we are surrogates to replace the author's voices in this talk?
Correct, Tommy. To achieve this goal, the authors had to find suitable training data. Luckily, there is the manuscript. Are we using appropriate segmentation metrics? Identifying correlates of human expert perception for CNN training beyond rolling the dice coefficient. There, 15 radiologists from 6 institutions rated 600 center of mass slices from computer-generated and manually annotated glioma segmentations for 75 exams.
Center of mass slices? Does it mean these are two-dimensional images?
Precisely, Tommy. The human experts rated the quality of segmentations on a scale from 1 to 6 stars based on the axial, sagittal, and coronal views of the three-dimensional segmentation maps. The surrogate models learn to predict the star ratings from T1, T1 contrast, T2, and FLAIR MR images accompanied by segmentation maps. In the figure, red symbolizes necrosis, green edema, and yellow enhancing tumor.
In the manuscript, BRATS label encoding is mentioned. What is meant by that?
That's right. Here, necrosis and enhancing tumor form the tumor core while all three labels combined represent the whole tumor. First, multiple network architectures, optimizers, normalization and label encoding strategies are evaluated on 15 of the 75 exams held back for testing. It turns out the training runs are quite robust concerning these hyperparameters as all models achieve comparable performance.
Nevertheless, a DenseNet 121 trained with Ranger 21, percentile-based normalization, and BRATS encoding achieves the best fit on the tested set.
Here, you can see the network predicted versus the human quality assessment.
It seems that the variance increases for lower star ratings?
Yes, however, it is important to note that the same is true for human raters. Expert assessments of segmentation quality also vary more for lower quality segmentations.
Oh, I just realized that the model predictions are usually in the spectrum of human ratings. For most cases, the network predicts a star rating, green triangle, that lies between the minimum, red dot, and maximum human rating, purple plus. But how well does the model generalize to other datasets?
To investigate this, the authors analyze a multi-institutional dataset consisting of 40 high and 28 low-grade glioma. Therefore, the authors obtain 612 tumor segmentations from Rat's toolkit and compute the correlation between predicted star ratings and volumetric dice coefficient.
It seems we again observe a higher variance for lower quality exams.
Indeed. However, it is important to note that in practice, it is sufficient to distinguish between low and high quality exams and that this can be achieved with a simple thresholding operation.
Oh, that is true. Using a threshold of around 5, I can detect all segmentations with a low dice score. What are future directions for deep quality estimation? DQE has interesting properties. It is fully automated, has split-second inference times, and being a convolutional neural network, it is also differentiable.
Yes, besides quality monitoring for clinical translation, DQE enables dataset curation in federated learning settings. Further, being differentiable, DQE can also be applied in loss functions for CNN training. With that, we want to end our presentation and thank you for your attention.
Please have a look at our manuscript, which you can find with the QR code, and join the discussion by visiting our poster.
We hope you enjoyed the vibe and wish you a pleasant day.